program itself is trivial. All the stuff that I program you can find built into MATLAB, but it's a good thing to illustrate what a program is. Okay, now remember what we had in these so-called scripts. It was just a bunch of MATLAB commands. Okay? Now, many times you want to write a function that does something. It has a fixed set inputs and outputs. So let's look at this one called stat.m that I wrote. Okay? So we've got a function on the top. See, this is new now. Okay? So when you write what's called a function program, the first line in there here's the name stat.m. Okay? It's called function. Okay? And then in brackets, you put in the output arguments. This function that I wrote is going to do the following. It takes in a vector x, and it'll just calculate the mean and the standard deviation from the definition. Right? You know, do that, right? Okay? But notice the syntax, okay? Function, okay, that's following me. You put a space, and then you put brackets. These are all the output arguments. It can be as many as you want. Sometimes it can be 0 even. Sometimes you can have something that, I don't know why you would have that, but theoretically you can have 0, okay? And then, notice basically here's the name of the function, okay? It could be anything that you want, okay? And now, unlike brackets, you put parentheses here. If there was 2 inputs to stat, say x and y, you put x comma y, okay? And of course you have to know, is it a vector, is it a scalar, but as long as you're consistent, it's okay, okay? Just match everything up. And of course, I spelled that wrong, okay? I need to point out this. This is comments in MATLAB, okay? You put an ampersand, and then anything on that line is a comment. So this is supposed to be function, computes the mean standard deviation of a vector, I guess, okay? And now we just apply, the definitions, right? Okay, what's x bar? Okay, it's just a summation I equals 1 to n of xi divided by n, right? Where n is the length, number of elements in x. Well, the first thing we do is we need n over here, right? I have to compute how many elements in x are. And the great thing about this function is that, it works in general. Like one guy comes in with an x of 1,000 elements, the next guy comes in with an x of 20. Doesn't make a difference, right? The x is an input argument. It now finds the length of x, puts that into n, okay? And what's the mean? Okay, I could do this in a loop, but there's a thing called sum that's built into MATLAB. Sum of x does exactly what you expect. It takes the element of x and just sums it. If you wanted to, you could put a for loop on that, okay? And then you'd have to do an accumulation, for I equals 1 to n, mean equals mean plus x of I, that type of thing. But this is shorter, okay? And then we have the standard deviation, okay? And standard deviation, is that the variance? Yeah, sigma, okay? And just this is right in normal notation. It's the square root of the summation I equals 1 to n of the average minus xi squared over n, okay? That's the definition of the standard deviation, okay? So let's look at the coding of that now. Okay. There's my big square root. Goes from here to here. Okay, so I got that. Now I go inside the square root. What do I need? Okay. Here's the division by n, right? Slash n. So there's the numerator. Now upstairs, let's see what happens. Okay. I really want to do the summation I equals 1 to n of the average minus xi, every element. Look how I coded it though. I put x, which is what? That's the vector minus mean. Now, mean is a scalar. What does x minus mean mean? That's a bit interesting. Well, how does MATLAB interpret x minus mean? We said before, if you take a vector and you subtract a scalar, MATLAB's going to basically proceed by subtracting that scalar from every element of x. So what happens is it becomes a vector. x1 minus mean, x2 minus mean, x3 minus mean. That's exactly what I have over here, right? And now I have to square every element of that vector, right? So that's why I got the dot square in there, right? I got the dot square because basically x minus mean now is x1 minus mean, x2 minus mean, and what I'm going to do is I want to take every element in that vector and square it, okay? So if I don't put the dot in there, it's going to try to take a vector and multiply it by itself. You can't do that. So this is why you can see how the element, by element operation is very important over there. Then divides by n, and that's it. Okay, so we come back on Wednesday, we'll run this, and then we'll compare it to MATLAB. Obviously MATLAB has a built-in meaning.